What do you see as the most pressing issue in urban planning and transportation today, and how can engineers address it?
Yeah, there's a lot of stuff. I mean, I've been a professor now for 15 years, so I'm probably 75 or so, published peer-reviewed papers. But a lot of that stuff, I feel like I'm sort of chipping away at the tip of the iceberg with some of the problems. Like the book, it was more meant to look at the foundation of a lot of what we do and understand that a lot of that isn't as strong as we think. So, I mean, some of the more foundational things, the one I've been hitting on a lot lately, especially when, people are asking me questions, is just the idea that human error is sort of the biggest problem we need to deal with when it comes to road safety and crashes.
How safe are our roadways in the United States? Are our roadways designed with the right science and engineering in mind? Well, in this episode, I have with me Wes Marshall. Wes is a licensed professional engineer. He's a PhD, and he's author of the book Killed by a Traffic Engineer, Shattering the Delusion that Science Underlies Our Transportation System. Wes is going to talk about how we need to change the way we design our roadways to make them more safe. Let's jump right in. But first, a word from our sponsor. Before we dive in, we'd like to recognize our sponsor for this episode, PPI, a leader in engineering exam prep for the FE and PE exams. PPI provides expert prep courses and study resources designed to help you pass the FE and PE exams the first time. PPI's live online courses include hours of lectures, problem-solving demonstrations, exam strategy sessions, office hours, and a passing guarantee. Check out PPI today at ppi2pass.com to see all the options available for FE and PE exam prep. Now let's dive into today's episode. All right, now I'd like to welcome our guest onto the show for today. Wes Marshall is a PhD, licensed professional engineer, professor and associate chair of civil engineering at the University of Colorado, Denver. And Wes, welcome to the Civil Engineering Podcast.
Hey, thanks for having me, Anthony.
No, we're really looking forward to talking a little bit here. And maybe to get going, you could just tell us a little bit about yourself, kind of what led you to civil engineering and, how you kind of became this author and really now a thought leader through your book that we're going to talk about. Take us through your career journey to get going.
So I went to University of Virginia and I was in the engineering school. And at the very beginning, we had to choose our, which, mechanical or electrical or civil, within the first 6 months. And at the time, I liked the idea of civil. It spoke to me. I thought, maybe become an architect or something. And, it's also broad. There's a lot of different things within civil. So you can sort of shift a little bit. And, it gave you a lot of options down the road. So that's where I started. And at first, we had to choose a concentration. So I chose structural. And, over time, I started doing more and more transportation. If you want to get into, where I worked, right after college, I started working for Sasaki Associates, and there's a lot of site engineering work, which is good because you get to do a little bit of everything, a little bit of structural, hydrology reports, stuff like that. You get to do transportation work as well. As over time, the transportation stuff started being way more interesting to me. It felt like with the structural work, and some level, the computer did all the work and the, beams needed to be only so big. But with the transportation stuff, it got to be a little more interesting when humans are involved. And, when I started seeing to some extent how a lot of the stuff we were building was, not as good as the stuff I saw in and around me in Boston. Over time, I ended up at Clough Harbor and Associates. I was in Connecticut, they're based in Albany, New York. I think they're just called CHA now. And, that's also when I first lived in a place where I really couldn't leave my street without being in a car. And it sort of drove me crazy. And I started kind of wondering why a lot of this stuff, why we do a lot of stuff we do within, transportation and civil. So right after I got my PE, I went back to school and did a master's and PhD. So that's sort of the progression. And sorry for talking so long there, but
no, it's good to it's good to hear the background. And I agree with you. I think once we start thinking about how much we drive and how reliant we are on cars, traffic becomes very interesting. And I think similar to you, I started maybe this is the life of every civil engineer. Started as a structural engineer because it sounded exciting to me, and then I ended up finding land development, which I didn't even know about till I graduated. But But it's always good to hear kind of the backstory of, and it is true that civil engineering is nice in that it has a lot of options and a lot of flexibility. And I think even with AI and technology, there are going to be things that civil engineers are doing tomorrow that they're not doing today, which I tell people all the time. But let's talk a little bit about, you recently published a book you authored a book called Killed by a Traffic Engineer. Talk about the whole reason for writing the book, and then a little bit about the book, if you could.
So why I ended up getting to the point where I wrote this book. I mean, part of it started with, when I lived in Connecticut, I lived in that street where I couldn't leave my street without being in a car. And it was so different from, where I grew up right outside of Boston. Like as a kid, I could walk or bike all over town. I really didn't think about transportation in the same way. But in Connecticut, I could see a store. It wasn't too far from me, and I really couldn't get there in anything but a car. And I would ask my neighbors about it, and, they didn't really know any different. They didn't seem to care. Like, oh, just drive there. Like, what's the problem? I'm like, well, it's right there. Like, can't we, do something else? And they're all chauffeuring their kids all over town. And I started to wonder why we did the things we did. And, I asked those questions at work. Yeah, there was a couple people that made time for it, but a lot of the older engineers, we have to get jobs out the door. Like, we didn't really have time to dig into the why question of why we do a lot of the things we do. So that's when I went back to get my grad degree. And I was, at the firm I was at, they said, you got your PE, like, what do you need a PhD for? And it's because I was curious. I had a lot of my things that drove me crazy, a lot of my pet peeves. Like, I really wanted to know why we do what we do. And then I started getting into academia where I had a chance to research these things. And, almost every time you sort of go down one of these rabbit holes, like one of the first projects I was on was parking. And we were looking at, parking regulations. We were looking at ITE parking generation. And this is before Donald Shoup's book came out, The High Cost of Free Parking. You start realizing, there's no science behind it. Like where are these numbers coming from? They're not meant to be used in any place that's even close or remotely urban, but we're using them in that way. And then when I started going down other rabbit holes, you see a lot of the same things. And what was always interesting to me is as an engineer, we're given all these 1,000-page guidebooks, right? And we sort of assume whoever wrote these knows more than we do. We assume they did their homework. We assume that, safety is baked into everything that we see in there. And, you start to understand that that's not quite true. A lot of times safety was an afterthought. And a lot of times we said we needed to add safety later, and we never did. So it's hard. Even though the title of the book, I know a lot of engineers feel attacked a little bit, but if you read the book, I'm not blaming them. I'm saying we're doing what we were taught. We think, we believe, and we have good reason to believe that there's science behind this stuff. And I'm trying to show everybody that it's not quite the case. Interesting.
Yeah. And I hear what you're saying about the PhD because I do think sometimes people will say well, you already got a license or whatever the case may be. Why do you need to get a PhD? But just hearing you talk a little bit about and thinking about the transportation or the traffic industry, there's so many things going on, right? Between, automated cars and all the different signaling that happens these days and these smart sensors in the roadways. If anything, I could see that there's so many interesting avenues to go down of kind of where we're headed at it with traffic and transportation that it seems like something that would really be worthy of having more people dig into it, quite frankly. Because like I said before, I think there's things we're going to learn that we don't even know yet. And it sounds like a lot of that stuff, or there's a lot of interesting stuff that you uncovered as part of your research and part of authoring the book. And I guess the one question I would have is based on what you've seen so far in your research and your whole process of writing the book, what do you see as the most pressing issue in urban planning and transportation today? And how can engineers address it?
Yeah, there's a lot of stuff. I've been a professor now for 15 years. So I've probably 75 or so published peer-reviewed papers. But a lot of that stuff, I feel like I'm sort of chipping away at the tip of the iceberg with some of the problems. The book, it was more meant to be look at the foundation of a lot of what we do and understand that a lot of that isn't as strong as we think. So, some of the more foundational things, the one I've been hitting on a lot lately, especially when, people are asking me questions, is just the idea that human error is sort of the biggest problem we need to deal with when it comes to road safety and crashes. If we approaching Vision Zero, when we want a data-driven approach to that, or safe systems. We all want that. It makes perfect sense. And you look at the data, what does it tell us? It tells us that, people were speeding, people were jaywalking, a lot of stuff like that. And if you take a step back, and at some level, yes, like, people have responsibility, want them to do better. Like, we need to, blame one or the other of the road users in a lot of cases for liability, for the police purposes. But, for engineers, a lot of times it lets us off the hook, because if you take a step back from, almost any one of those crashes, and you understand, well, take a look at maybe the built environment around, like, where this person was jaywalking, and you can see the nearest crosswalk was like a half mile away. And even if you go to that crosswalk, it's not that safe. And we didn't even give them decent sidewalks between where they are and where they're going. And where they are is where they live, and maybe where they're going is a school across the street. So you take a step back, and what they did wasn't an error. Like, they were doing a very rational thing. And like, the way our data is pushing us is thinking that, engineers had nothing to do with it, and like, these people just need to do better. And if everyone just followed the rules of the road, we'd all be safe. And it's not quite true. I mean, a lot of these crashes aren't the random events we treat them as. They're systematic. Like, we know where they happen. If we take a step back and understand why these road users did what they did, we can understand why the crashes are happening too, and try to treat them more with engineering.
Yeah, no, it makes a lot of sense. And actually, what I want to do real quickly is I'm going to read. Well, first of all, the full title of the book is "Killed by a Traffic Engineer: Shattering the Delusion That Science Underlies Our Transportation System," which I think is important to say, because if you just read the first part, like you said, "Killed by a Traffic Engineer," if you're an engineer, you might say, well, geez, this author's out to get me. But then I also want to read a little part of the description of the book, which is important, which says, "Killed by a Traffic Engineer shows how traffic engineering research," in quotes, "is outdated and unexamined at its best, and often steered by an industry and culture considering only how to get from point A to point B the fastest way possible." And I think that that's really the world we live in today. People want to get there ASAP, and that's what they're thinking about. And so, again, it's interesting that Wes has kind of dug into this to try to really understand what's behind it. And obviously what he found, which is in the book, is not a lot. And a lot less than you would think, I guess, is a way that I can say it, essentially. And so let's talk a little bit about this concept, Wes, designing for people, and how that can maybe change the way we think about infrastructure projects.
I mean, you could take a simple example from here in Denver. For decades, we always would count vehicles, right? We would do vehicle counts. We try to design for the peak 15 minutes, or, the peak hour, for intersections, or for corridors, whatever it might be. And Denver just made a change where they're going to, instead of counting vehicles, they're going to count people. All of a sudden, that gave them the wherewithal to take a corridor, like the one right behind me, 15th Street. It used to be 4 or 5 lanes of one-way traffic in downtown Denver. Yeah, maybe 10 years ago, they added a bike lane, eventually became buffered and protected. They're trying to do better for transit service. And by just switching the metric from designing for car counts to people, it gave them the wherewithal to switch 2 of the lanes to bus only. So now there's only 1 or 2 car lanes, there's 2 bus only lanes, and there's a protected bike lane. It's totally revamped the city. I mean, so that's like an actual metric. But when you think about, just designing for humans instead of cars, like, and you start putting yourself in the position of what it's like to be somebody using transit, or what it's like to be biking on a road, on an arterial with cars next to you that are 50 plus miles an hour, you start maybe having a little bit of empathy in your design, and understanding, that these people are still trying to get to where they're going as well, and doing it the best they can given the built environment and the transportation system we put in front of them. And you start to realize that we can often do better, and it doesn't take much to do that.
Yeah, that's really interesting if you think about it, just changing one of the variables in the equation, if you will, because if you're just looking at number of cars, you can, kind of like Wes is saying, just divide it by the number of lanes you think you need to get in, and there you go. But if you're now thinking about the number of people, and you could fit 20, 30 people in a bus, that's going to maybe change things quite a bit, or a bike lane like Wes suggested. So I really like that idea of maybe thinking about different variables, different what's involved in terms of your designing.
I mean, even if you take there's standard protocol to design any street, any corridor, and we're not just designing for the number of cars or people today. We're trying to do it for like 20 years in the future, right? So we're often so focused on figuring out how many cars we might have 20 years from now and making sure we accommodate that. And by doing that, we're missing the people that like live or work on this street today and how it could be best, how it could be safest. And, those protocols that are all focused on capacity, we sort of assume safety is kind of baked into that, but it's often not. I mean, it really has nothing to do with safety. It's really just thinking about our future capacity. Yeah, so there's a disconnect there.
Yeah, for sure. For sure. And, we hear so much these days about like smart cities and, like I said, AI, automation, new technologies. Based on what you've seen in your research, what do you see with all of this technology emerging for civil engineers, both from opportunity standpoint and also challenges?
I think a lot of us see it as the panacea. Like, we feel like it will solve the safety problem. Like, if we assume, talking about the human error thing, that 94% of our fatalities are human error related, and, you think that autonomous vehicles will just remove the human error from the equation, you sort of think that we'll remove 94% of the fatalities. And, I'd be hard pressed to believe that, because in reality, like, when you look at autonomous vehicles or, something like that, like, we don't get a lot of the benefits unless everyone is in them.
Right.
I remember one time I was in Australia for sabbatical, and, this guy from MIT was there, and he showed an autonomous intersection versus a conventional one. The conventional one was delayed, and there was a really cool animation he was giving us. And the autonomous one, like, every car is getting this reservation, and it was going through the intersection with just amazing speed. And like 200 people gave him a standing ovation, and he declared this the future of urbanism. Right. I'm like, wait, what? Like, what if there's one pedestrian, like one cyclist, like one human driver? Like, none of this works. Like, this might be the future of the middle of nowhere, but it's not the future of urbanism. And like, even if you're looking at more small scale stuff, like, when a lot of newer cars have the ability to see a pedestrian and stop for that pedestrian. But when you actually look at the data, it works pretty well during the day. It's about 50-50 at night. And it's actually less so the darker the person's skin is.
That's interesting.
So with a lot of these things, you would think if we add that technology to what we're already doing today, it would be a clear safety benefit. But what ends up happening is people are human. They behave differently when they know the technology is helping them out. And, you might look down at your phone a little bit longer than you normally would have because you feel like the car will stop for a pedestrian. And, one of my neighbors, I remember we were driving up to the mountains here in Denver 10 years ago, and he just got one of the cars that would tell you if there's a car in your adjacent lane. Right. So he was changing lanes and not even looking. I was like, what are you doing? Like, you're not going to look? And he's like, oh no, the car will tell me if there's another car there. I was like, well, great. But what if it's wrong? What if your car's dusty and it misses one? Like, again, you would think you would add safety if he still looked over his shoulder or used his mirror and then used the technology in addition to it. But when you start relying on the technology entirely, the safety benefits aren't as clear cut. So technology, big picture, it's always been this dangling carrot 5 years in front of us is going to solve all our problems, but it's been that way for decades and it hasn't done it yet.
Yeah, and I think really what it's going to require is for civil engineers to kind of balance this technology with some of the practical constraints that they typically face on projects, right? Because you want to leverage the technology where it makes sense, but you also have to, like you were saying before, if it's one car, it's great, right? But
yeah, no, I mean, there's going to be a lot of useful things. Like if an older person or kid is crossing the street and taking more time than we've given them, it might be able to see them and provide them with more time. When you think about a big picture, though, I have a hard time getting super excited about like a Hyperloop when we can't even get the sidewalks right in most major cities.
It's true.
So there's fundamental things I think we need to start with first and then bring technology in later.
Yeah, it reminds me a lot. We do a lot of project management training at EMI for large companies. And what always fascinates me is how everyone wants the software, right? The big shiny PM software, like it do my scheduling, it could do my budgeting. And we're always like, listen, the first thing you need to learn is really how to build a budget and really how to build a schedule, like on a napkin first before you start getting into a software, because that's not what you need to rely on. That can maybe make you faster, help you manage a project better, or maybe juggle multiple projects a little bit more efficiently. But at the end of the day, you want your project managers to understand what scoping is, how to really to schedule dependencies, durations, et cetera, and build a budget. So I think the same thing applies here with the technology. Is like you're saying, if we know how to fundamentally and basically design a road and a sidewalk system, that's a good starting place. And then we can look at ways that we can improve that with technology in the future. But if we can't kind of crawl before we walk, we got a problem.
Yeah, no, that's a good corollary. In a lot of things, like you need the foundational basics. And if we skip and try to hope technology is going to fix those things without us getting the fundamentals right, it's not going to work.
Yeah, for sure. One other thing I wanted to ask you about was, we hear a lot about diversity and inclusion in our industry. And I'm wondering from a kind of a design and infrastructure project perspective, how can civil engineers ensure that infrastructure projects really do benefit, all communities, even underserved communities? Because I think sometimes people don't realize we have the ability to think about that.
Yeah, I think, engineering, becoming a transportation engineer is, again, like civil, it is so broad. You could be doing a lot of different things in this world. You could be designing like pavement cross sections, or you could be going to communities to talk to them and engaging with them about, a potential bike lane coming through their neighborhood, right? And, historically, I think we treated public participation as sort of a box we needed to check off in projects. I know that's how it was at the firms I worked at. Like, we've already decided what we're going to do. We've already designed it. And we were just there to let everyone know what was happening and check the box and move on with the project. By that point, we weren't there to really get real feedback and real understanding. So I feel like we need, a broader, more diverse set of people that are working as professionals in this world to be able to better engage with these communities and understand their real needs and understand how it works. At the same time, though, like I hate to see it when something that is, will help safety gets shot down from a vocal minority in a public meeting, right?
Right.
A structural engineer would never let the public tell them how big a beam needs to be, right? Like, it is what it is. And at the same point, you could think, a lot of transportation is network. So if we don't have a bike facility on a certain street, but we have it on one on the other, like, we're not going to get the safety benefits. We're not going to get, the lower stress for the type of people that might want to get out there and ride. So we need to think of it that way. But at the same time, we're the same people that forced highways through lower income neighborhoods in the 50s and 60s. So
right.
We perpetuated a lot of wrongs. So you can understand why people want us to make sure we're engaging the public thoughtfully and better than we did in the past.
Yeah. In fact, that was one of my summer reading books in college, The Power Broker, talking about how, I think it was Bob Moses. They kind of went through communities.
Did you finish that within the summer? It's a long book.
I think I tried. I don't know. I was in college, probably not. I got the gist of it though. But no, I think to your point, again, it comes down to practical. Like, we want to have a collaborative approach, but at the same time, we also need to understand the engineering behind it, and that there are certain things that the engineering must dictate for safety purposes. And I think collaboration helps, but I do think it's on us as a community too, to get out there to some of these communities, to these kids that are younger, and get them exposed to engineering. And I know we've done a lot with that, and the civil engineering industry has done a lot with that. I know ASCE has been very good with that, but I think companies need to do more with that.
Well, and I'd also like engineers to honestly realize that a lot of the stuff that we are doing for the sake of safety isn't that. And that's a lot of the stuff I'm covering in the book. Like, something like, forever I was told like wider roads are safer in a lot of cases. And like I was trying to figure out like where that originally came from. And the studies that said that were from the 1930s and 40s. And they looked at, roads that were 18, 20, 22, 24 feet wide. And in that study, it said that 24 was safer than 18. And, 10 years later, we stopped even citing that study. And we just sort of moved on. And just the idea that wider roads are safer perpetuated through time. If you go back and look, it is not always quite the case. And that's the same thing with a lot of things you see. Like, I've always been told that, the pace of the speed of cars matters more than the raw speed. Like, as long as everybody is in the same 10 mile an hour, pace, that will be safer, even if the pace is at 70 versus 50.
Right.
And like the original studies that came up with it, like Solomon did these studies, and they're so flawed, and there's so many like later research that debunked it and showed that speed is actually a safety problem and we should be designing things differently. But a lot of us are still thinking that that is the truth, that, pace matters more than raw speed. And so I think we also need to take a step back and look at the empirical science versus what we actually are doing and thinking when it comes to trying to make the world a safer place.
Yeah, I mean, I think I would agree with that. I think the one thing that has to be factored in, and again, I don't have a PhD and I'm not researching in transportation world, but I have done some research myself around people's attention spans and their focus. And I think that you have to consider the driver these days, like a wider road, whatever. In the past, like in 30, 40, 50, 60 years ago, people weren't distracted by a lot of stuff when they got in the car and they were driving. And now people are, and people have a different pace about them. So I think that when you look at those studies from the past, you also have to understand the subjects. The subjects are completely different now.
No, I found a study basically saying that older drivers didn't have, different perception reaction time as younger drivers. And the study was, almost 100 years ago, and the older drivers were all like 50.
Right. That's a perfect example, right? So Wes, last question for this segment here, just about for those transportation engineers, those getting into transportation, the traffic world, what career advice, just from your experience so far in your career, what are some things that you can, share with them about like building their career in the transportation industry?
Well, I think, the best thing you can probably do is, move beyond your undergraduate. I mean, this is like when I did my undergraduate, I took one transportation course. I got my PE in transportation, and then I went back and got my master's, and I realized I knew nothing. You end up taking 10 more classes in transportation. And, I thought maybe a lot of other people are taking, far more transportation courses than I happen to. And when you look around, that's not the case. I mean, some people are taking 2 or 3, but most are taking 1, maybe 2. Some undergraduate civil engineering BS programs will have 0 transportation courses. And the way the accreditation works, you don't even need one. So, and one of our professors here, she was working professionally. She had her PE for decades, and she had never taken a single transportation engineering course in her life. Wow. And it's like, what are we doing? So I think, to really get into this field, you need to dive into this a little bit. And if you're passionate about it, like those courses will be so much more useful to you than a lot of the courses you took as an undergrad that, all the structural courses, like they're useful for structural, but that factor of safety mentality does not work in transportation in the same way. When we design a culvert or a bridge with a beam, like the bigger the better, but it's not the case in transportation. So that mindset doesn't bode us well. You need to start digging deeper.
Yeah, I agree with that. And I tell you, just from my own experience that I'll share, I have a master's in civil engineering, and I did it while I was working. And I thought that was pretty helpful too, because I went at night for a couple of classes, and then I was learning in the day on the job on some real projects. And then I was, and the professors also were given some examples because some of them worked in the day. So I feel like I got a good cross section, but I do agree with you. I mean, listen, you take a couple of transportation classes, a couple of geotech, a couple of structural undergrads. And then you're going to pick one of those fields. So it is a heavy lift to go from that into the projects. But yeah, so I think some additional education, absolutely, whatever it may be for you, can absolutely be beneficial, probably in all walks of civil engineering.
Oh, yeah, that's what makes it so hard for us to use engineering judgment on the job, right?
Right, right.
I'd only taken one transportation course, so I have to use those guidebooks that are handed to me, all these 1,000-page guidebooks. I don't know enough to do anything differently. But if you just follow those guidebooks to the T, you can see where it's led us in terms of safety and that we don't have good outcomes.
Yeah, for sure. All right. So what we're going to do is we'll take a quick break with Wes. We're going to come back. We're going to finish up by putting him on the civil engineering hot seat. We'll be back in just a minute. All right. We are back with Wes Marshall. Wes is author of the book, Killed by a Traffic Engineer, Shattering the Delusion That Science Underlies Our Transportation System. All right. We're going to wrap our time up here with Wes with a couple of career questions. You ready, Wes?
Yes, I am.
All right, here we go. First one. Do you have any specific rituals or routines that you practice every day? For example, whether it's a morning routine or a lunchtime routine, or just something that you do regularly that's contributed to your success?
I do a lot. And that's a tough question. One of the things that has really helped change my perspective is bike to work. It totally changes the way you view a city. Like that, the speed at which you're biking, you don't get sort of the windshield bias. When you're moving past things at 30, 40, 50 miles an hour, you don't see the same things that you do as a bicyclist. And you start understanding intersections a lot differently. So I take the time sometimes to stop and watch an intersection, for like 10, 15 minutes sometimes. And you see how differently people behave there than sort of what we expect and what we do. And it changes your mindset on things like design as well.
That's interesting. Let me ask you this, just from one author to another. How about your writing? Like when you wrote your book, did you have any routine, or was it kind of writing whenever I could?
The pandemic helped me. I like having a lot of free time to lock myself in my office, and nobody was knocking on my door for quite a long time. And, to do this research, I had to literally read 1,000 old journal papers and books from the 30s, 40s, 50s. And
right.
I had, 1,000 pages of notes, and trying to kind of put together that jigsaw puzzle was a part of it. And to be honest, a lot of my time thinking about these things was on my bike commute, and that helped a lot. At the same time, as a professor, like I mentioned before, I've, dozens of academic papers, but it's such a different thing. So with this, I treated it very differently. I tried to, let it be a little bit more personal. I tried to let my voice come out to some extent. And I'm also literally writing about kids dying. So I had a little bit of levity from time to time, but there's still tons of research in there. So in terms of, the writing, I try to keep it where everything had a story to it. Like in the book, even though it's a long book, 400 pages, there's 88 short chapters, and every chapter is a beginning, middle, and end. And each part of the book, there's 12 parts. There's still these overtop, lying stories within each of those parts. And in the end, I think it works well as opposed to just stating facts. Part of it is storytelling.
Yeah, for sure. So on the topic of books, has there been a book or an author or a framework or something in your career that you've read or you picked up on that you held on to, that you took with you and that's been useful for you in your development?
Yeah, it's funny. I feel like if I just listen to transportation related podcasts or transportation related books, my research, my thinking becomes kind of boring. So I try to venture out to other stuff, listen to a completely off topic podcast or completely off topic books, and you start getting ideas for our world. So in the book too, I was we need to be a little bit of a generalist, not just a specialist. We need people that can understand what it means to have a highway come through your community, what it means for public health, what it means for air quality. And you have to have a greater skill set than we sort of provide in our current kind of civil engineering education, to maybe have understanding of some of those things. So, broaden your horizons to some extent is what I suggest.
I like that. Yeah, get outside of your own industry a little bit. So if you think back on a manager or a mentor for you in your career, is there, and you don't have to name names, but what was it about those people that were the great characteristics for those that mentored you or guided you in your career? Trying to understand what makes for a great manager or mentor in civil engineering.
I have to immediately point to my PhD advisor, Norman Garrick at the University of Connecticut. He's now retired. He's living in Zurich, but he grew up in Jamaica and he went to Purdue for his PhD, and he was a pavement engineer. He was designing the cross sections, how much asphalt, how much gravel, that sort of stuff. That was his research. That was his world. And he was, I think, close to quitting his tenure job at University of Connecticut. He ended up taking a sabbatical in England, and it totally changed his thinking on transportation and what it could be and what it could be like. So he changed everything he did. And by the time I got there, he was, deep into thinking about things like new urbanism and the way land use plays such a big role in this stuff. But the way he taught me to sort of look at things and to sit at an intersection for 50 minutes and just watch to see how it works and start realizing it looks nothing like my micro simulation. And there's a huge disconnect there. Things like that. Trying to think about things from that human standpoint was such a, kind of big difference than what I was experiencing in the workplace. Like I worked for 7 years in consulting, and most of it you're sitting behind a CAD monitor, right? You're doing like micro simulation. You're not actually getting out there and thinking about things in the same way. So, to some extent, that's my advice is think about these things and ask why. Like, don't just assume everything we do will lead to safety, will lead to better places. Like sometimes you have to ask, well, why is this the case? Like I know plenty of empirical examples that it works, even though they technically be illegal to build today. And, a lot of places, I'm sure it's the case in New Jersey where you are, like the most favorite places people go in a lot of these cities like that are, the streets are too narrow. We couldn't build streets like that today. Like there's not enough parking. We couldn't build places without little parking today. But those are people's favorite places. They're safe. People love them. They go out of their way to go to these places. But yet we built a system where it's almost impossible for us to recreate them, even though we know they empirically work.
Yeah. Yeah. I had a project as a civil engineer where it was an old car dealership that was abandoned, and a company was coming in with like a plumbing supply wholesale. And the planning board was just battling them, and they were making them do all kinds of traffic plans and parking. And at the end of the day, they almost lost this company. And finally we had to tell them, like, listen, this site worked for a long time. And now a company wants to come in and bring jobs and everything else. And you're going to scare them off by making them do 100 million template design. So I think to your point, like sometimes we're trying to over design things when what was there worked, right? And we can always make improvements, but we also have to understand that, it's there for a reason, and it lasted for a long time for a reason.
Yeah, and get out there and like measure that street. I mean, see how actually wide it is, and like measure the turning radii on the corner. And you're like, oh, like I can't do that today. Why not? You can see buses making these corners perfectly fine, but our current regulations don't really allow us to do that.
Absolutely. All right, Wes, I got one more question for you. Let's imagine that you got into an elevator with a civil engineer kind of starting out their career. You get about 30, 40 seconds with him or her, and they're looking for just career advice to get them going in your career. What would you tell them in that short amount of time?
Follow your passion. Probably want to ask them more than hear what they had to think rather than them listening to me talk. But, that's what I did. I followed my passion. A lot of times my passion and curiosity led to things that drove me crazy. I think my pet peeves. I sort of built my career off of studying those things. So yeah, I think that's part of it. And I think when you think about transportation, we all bring so much to the table. Like we've all experienced this. It's such a different discipline than most other things where you don't bring as much at the table in so many other disciplines. So use that. I mean, and try to understand where that fits into what you're being taught in school, what you're being taught in the workplace.
That's great. Awesome. All right. Well, once again, Wes Marshall. Wes is a licensed professional engineer, author of the book Killed by a Traffic Engineer, Shattering the Delusion That Science Underlies Our Transportation System. We'll absolutely link to his book in the show notes here. And Wes, thank you so much for spending some time with us here on the Civil Engineering Podcast.
Thanks for having me on the Civil Engineering Podcast, Anthony.
I hope you enjoyed my conversation with Wes. When you think about it, we should really be researching as much as we possibly can about traffic and transportation because of everything that's evolved, the driver, technology, automation, all of those things. And I hope that you found my conversation with Wes useful. If you liked it, please subscribe to our channel here. We do put out videos like this on a weekly basis to help engineers become better managers and leaders. I'll see you